awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Hai, Assalamualaikum. Jom kita revise sambil berehat. Sambil berehat pun, kita boleh belajar tahu dengan tengok handphone. Apa tunggu lagi? Jom kita mula. Assalamualaikum and hi everyone, welcome back to my channel. Jika anda pertama kali hadir ke channel ini, selamat datang saya ucapkan. Jika anda pernah hadir dan kembali semula, tahniah kerana rajin dan sudi kembali. Jadi dalam video kali ini kita akan discuss lagi 10 soalan berkaitan dengan subtopik 8.1 iaitu Rotational Kinematics. Tapi sebelum kita discuss soalan-soalan yang berkaitan dengan subtopik 8.1, apa kata kita tengok dulu equation yang penting yang terdapat dalam subtopik ini. Okey? So kita mulakan dengan terms yang pertama dalam rotational motion. Okey? Kita refer kepada angular displacement. Okay, so dalam rotational motion kita akan jumpa angular displacement and the symbol is theta, and it is actually the angle undergoes from a fixed reference point. Okay, apa maksudnya dekat situ? Contohnya kita ada satu bulatan. Okay, jadi saya lukis dekat sini. Okay, saya lukis kecil saja. Okay, so let's say this is the center of the circle and this is the reference point. Okay, so if the object is rotating from point A to point B, for example, okay, so this is point B and this is the angle theta. Alright, let's say the angle in degree is given as 30 degree, for example. Tapi kalau kita sebut angular displacement traveled by the object, kita tak tulis unit angular displacement dalam unit degree. So we need to change 30 degree kepada radian, unit radian. Okay, so kita tahu one revolution, satu bulatan lengkap bersamaan dengan 360 darjah. Okay, kalau separuh, half revolution. Okay, kalau half revolution, it's actually equal to 180 degree. Okay, and one revolution is equal to 360 degree, and dalam radian it is equal to 2 pi radian. Okay, and half revolution, separuh bulatan, it's equal to 180 degree. Okay, dan dalam radian ianya bersamaan dengan pi radian. Okay, jadi kita kena tahu dalam chapter 8, unit untuk angular displacement adalah radian. Okay, so radian. So second part, we have average angular velocity. Okay, average angular velocity. So definitionnya adalah rate of change of angular displacement. Okay, kita ada omega, average angular velocity omega is equal to final angular displacement minus initial angular displacement and bahagikan dengan the change of time delta t. And remember, the unit of omega is radian per second. Jadi kalau soalan bagi kita 1 revolution per minute, itu sebenarnya adalah maklumat berkenaan dengan angular velocity. Okay, 1 revolution per minute means that dalam masa 1 minit, okay, objek itu boleh melakukan satu putaran lengkap. Okay, so 1 revolution per minute. Okay, 1 revolution in 1 minute maksudnya. So kita kena tukarlah 1 revolution, unit revolution kepada radian and minute into seconds. Okay, kalau yang kedua ini adalah 1 revolution per second. Okay, so kita kena tukar 1 revolution per second, tukarkan kepada radian per second. Okay, itu yang kena tahu dulu. So kalau saya akan tulis macam mana kita nak tukar revolution kepada radian. So I will write 1 revolution per second. Okay, so 1 revolution is equal to 2 pi radian. So bila kita cancel, so kita akan dapat 1 revolution per second is equal to 2 pi radian per second. Boleh? Okay. And then the next equation is about average angular acceleration. Okay, so the rate of change of angular velocity. So kalau tadi kita ada average angular velocity, this time is average angular acceleration, alpha. Okay, so alpha is equal to omega f minus omega I over t final minus t initial. Boleh? And kita ada juga instantaneous angular acceleration, means that if we have equation of omega, so differentiate equation omega d omega over dt will give you equation of alpha. Okay, so definition for instantaneous angular acceleration, it is the rate of change of angular velocity at a specific time or position. Boleh? And the last one, okay, ingat lagi tak formula ni dalam chapter 2 kita ada jumpa vuad, sutat, vuas. So dalam rotational motion, look at here, we have kinematics equation of rotational motion. Okay, and in this case alpha is constant. Okay, so remember in linear motion we have v is equal to u plus at. Alright, v squared equal to u squared plus 2as, and the last one we have apa lagi satu, s equal to ut plus half at squared. Okay, kalau kita compare kan, v dekat sini linear velocity, here we have omega, u partnernya adalah omega naught, a is alpha. Kalau time ni time lah, tak perlu ubah apa-apa. Okay, so another important tips, alright, so you must know that if the object is slowing down, okay, so the value of angular acceleration dia akan jadi nilai negative. But if the body or object increase its angular velocity, means that the body is getting faster, so the value of alpha should be positive value. Boleh? Dan dalam subtopik ini paling penting lagi sekali adalah relationship between linear and rotational. Jadi yang pertama kita ada s, and second we have v, linear velocity, okay, is equal to r omega, and the last one we have a, which is tangential acceleration, is equal to r alpha. Okay, jadi ini yang penting lah yang you kena ingat dalam subtopik 8.1. So sekarang kita akan buat soalan yang pertama. Jom kita mula. Okay, question number 1. We have a 2 meter radius wheel spins at a constant angular speed. So let's take out all the information given. Okay, so here we have r, which is equal to 2 meter, and angular speed omega, okay, is equal to 24 radian per second. So the question state that constant angular speed, okay, means that omega is constant, okay, and how many revolutions will the disc go through in 5 minutes? So we want to calculate how many revolutions. Okay, bila perkataan revolutions means that we need to calculate what is the angular displacement. Okay, kita kena cari angular displacement, dan yang kita dapat nanti adalah dalam unit radian, dan kemudian kita mesti tukar dalam unit revolutions. Okay, so part A, since we know that angular velocity is equal to theta over time. Chapter 2 kita ada jumpa kan sebelum ni, v is equal to s over t, but this is for linear motion. So in rotational motion we have omega, okay, v partner dia omega, s theta, t adalah time. Okay, so we want to find angular displacement in 5 minutes. Alright, so saya highlightkan 5 minutes, make sure you change to seconds. Okay, so make sure you change to seconds. So 5 minutes is equal to 300 seconds. Alright, so theta is equal to omega t. So substitute omega is 24 and t is 300 seconds. Alright, so theta is equal to 7,200 radian. Okay, apa yang kita kira itu unitnya mesti dalam radian. Therefore, we want to change 7,200 radian into revolution. Okay, so radian dekat atas, radian dekat bawah, satu putaran lengkap, one revolution, okay, equal to 2 pi radian. Okay, so kita boleh cancel yang ini. Okay, so 7,200 bahagi dengan 2 pi. So, boleh buat darab silang macam ni kalau you confuse nak bahagi 2 pi ke darab 2 pi. Okay, so finally, theta is equal to 1145.9 revolution. Okay, so this is the answer for A. And B, how far along the ground? Okay, bila soalan sebut how far along the ground, okay, means that it is about linear displacement. Okay, so let's say this is the wheel, okay, and then it will spin until this position. Kan, dia spin selama 5 minit tadi, 1145.9 revolutions. Okay, so berapa ni? Okay, how far, sejauh mana along the ground. So, what is the value of S? Okay, so how far along the ground will the wheel travel at this rate in 5 minutes? So, remember the relationship between linear distance and also r theta, angular displacement. Okay, relationship antara S dan theta. Okay, so ini kena ingatlah. Boleh? So, kita hanya masukkan sajalah nilai. S is equal to R is 2. Okay, this one must be in radian. Mesti dalam radian. Okay, must be in radian. Must be in radian. Okay, and then the answer S is equal to 14400. So S is equal to 14400 meter. Okay, so finish example number 1. So let's proceed to the second example. Okay, now example number 2. So we have a disc speeds up from rest at a constant rate of 2.5 radian per second. Okay, so ni betulkan unit ni. Okay, the radian per second, negative 2. Okay, so let's take out all the information. So means that it start from rest. So omega naught is equal to 0 radian per second. Okay, so the angular acceleration is 2.5. Okay, so questions ask us to find what is the final angular speed of the disc after 18 seconds. Okay, so we need to use equation of kinematics of rotational motion. So based on the informations given, so we can use equation omega is equal to omega naught plus alpha t. Okay, so we just substitute all the information that we have, so we can find omega. So now this one is 0 plus theta is 2.5 and it is 18 seconds. Therefore, omega is equal to 45. Unit jangan lupa, 45 radian per second. Okay, and then B, how many revolutions will the disc go through during this time? Sama macam soalan yang pertama, kita nak kira berapa putaran yang telah dibuat oleh disc tersebut. Okay, how many revolution? Referring to the angular displacement, theta. So, we need to find theta first. Okay, so let's use this part. So, B, so we want to find theta. Okay, and then kat sini dia ada bagi radius of the disc, okay, which is 0.5 meter. So, now let's find what is the number of revolution. Tapi sebelum tu kita cari dululah theta. So, I will use equation omega squared is equal to omega naught squared plus 2 alpha theta. Okay, so based on this equation, we can find theta, okay, angular displacement dalam unit radian, belum lagi dalam unit revolution. So, we can substitute 45 squared, omega naught is 0, plus 2, alpha is 2.5, and theta. Okay, so the answer is 405 radian. Okay, ini masih dalam unit radian. Okay, so soalan minta dalam unit revolution. Okay, so we need to change to revolution. Okay, sama. Jadi sama cara macam tadi, 405 radian times. Okay, radian dekat atas, partner dia duduk bawah. So 1 revolution equal to 2 pi radian. Mesti ingat 1 revolution equal to 2 pi radian. Okay, so bila kita kira, kita akan dapat 64.46 revolution. Okay, therefore the number of revolutions, okay, is equal to 64.46 revolution. Okay, so this is the answer. And the last one, what is the linear speed of a point at the edge of the disk after 18 seconds? So we want to calculate the linear speed V. Okay, and kita dah ada omega. After 18 seconds, kita dah tahu nilai omega kita tadi 45 radian per second. So part C, we can find V by using equation R omega. So the relationship between V and omega adalah V equal to R omega. Okay, so we can just substitute R is 0.5 meter and then omega is 45 radian per second. So the answer, ingat yang kita kira ni adalah V, linear speed. So the unit should be in meter per second. Okay, so finish example number 2. Okay, example number 3. 3A, a disk with a diameter of 60 cm. So baca betul-betul, kita ada diameter dekat sini. Means that the radius is equal to 0.3 meter. Okay, diameter bagi 2, you dapat radius, and make sure the unit is in meter. And the disk speeds up from 20 radian per second. So means that omega naught is 20 radian per second. And omega is equal to 40 radian per second in 5 seconds. Okay, so T is 5 seconds. Okay, so this is for question A. And then number 1, so how many revolutions will the disk go through during that time period? So we want to calculate theta. Lagi sekali, kita nak kira theta. Okay, tapi sebelum kita cari angular displacement, we can find first what is the angular acceleration. Okay, so we can use omega is equal to omega naught plus alpha t. Okay, so when we substitute all the values, so we actually can find the angular acceleration. Therefore, alpha is equal to 4 radian per second squared. Okay, and now, okay, we can find theta by using equation omega squared is equal to omega naught squared plus 2 alpha theta. So again, we can substitute 40 squared equal to 20 squared plus 2. Alpha tadi kita dah jumpa. Now we can find theta, where theta is equal to 150 radian. Tapi masih belum selesai ya, unit ini dalam radian. So we need to change into revolution. Okay, so ini adalah method yang pertama. Ada yang tanya, boleh tak kita guna equation? Straightly use the fourth equation, theta is equal to half omega naught plus omega times t. Tak perlu cari alpha. Jawapannya bolehlah. Sebenarnya equation yang keempat ini adalah derivation daripada equation yang pertama dan equation yang kedua ini. Okay, so kita simplify, kita dapat satu equation without unknown of acceleration, angular acceleration alpha. Okay, so kita boleh dapat teruslah. Jadi kalau kita guna formula ni, kita memang terus boleh dapat theta is equal to 150 radian. Okay, mana-mana cara pun boleh, tak ada masalah. Okay, jadi sekarang bila kita dah dapat angular displacement 150 radian, okay, jom kita tukar kepada revolution. Radian duduk dekat bawah. Okay, 1 revolution is equal to 2 pi radian. Bahagikan dengan 2 pi. So, you akan dapat jawapannya 23.87. Okay, so theta dalam unit revolution is equal to 23.87 revolutions. Okay, so ini jawapan untuk A1. And then, what is the average angular acceleration of the disk? So we want to calculate the average angular acceleration. Okay, sebenarnya kita dah kira tadi 4 radian per second. Kan? Okay, tapi kita boleh tulis lagi sekali lah. Dekat sini, theta average is equal to omega final minus omega initial over T final minus T initial. Okay, so we can substitute 40 minus 20 over 5 minus 0. Okay, and then the answer is 4 radian per second squared. Unit jangan salah. Okay, now question B. A merry-go-round rotates such that it completes 10 full revolutions in a time of 13 seconds. 10 putaran lengkap dalam masa 13 saat. Laju Okay, so calculate the average rotational velocity of the merry-go-round in radian per second. So we want to calculate what is the omega. Okay, omega average is equal to theta final minus theta initial over T final minus T initial. Okay, jadi soalan dah bagi theta is equal to 10 full revolutions. So we need to change to radian. So 10 revolution, okay, tukarkan kepada radian. 1 revolution is equal to 2 pi radian. So kena darab dengan 2 pi. And you akan dapat theta is equal to 62.83 radian. So kita dah ada nilai ni. And then this one should be 0 lah. Okay, so this one should be 0. Okay, so when we substitute, so 62.83 minus 0 over T final 13 seconds minus 0. And then omega average is equal to 4.83 radian per second. Okay, so finish example number 3. So let's continue example number 4. Okay, now let's continue example number 4. So to throw a curved ball, a pitcher gives the ball an initial angular speed of 157 radian per second. Okay, so let's write the information given. So we have omega. Okay, so omega naught is 157 radian per second. When the catcher gloves the ball at t 0.795 seconds later, its angular speed has decreased to, okay, means that omega final 154.7 radian per second. Okay, so now A, what is the ball's angular acceleration, assuming it to be constant? Okay, this is very simple, right? So we just use equation omega is equal to omega naught plus alpha t. Okay, so when we substitute all the information, kita dah tengok omega pun dah dalam unit radian per second. So unit yang betul. Okay, pastikan kita masukkan nilai yang betul lah. Okay, so now we want to find alpha, and this is 0.795 seconds. Okay, so alpha mesti dapat nilai negatif. Kenapa saya cakap macam tu? Sebab dia punya angular velocity is decreasing from 175 to 154.7. Okay, so alpha is equal to negative 2.89 radian per second squared. Okay, unit jangan salah. Boleh. Okay, question B. How many revolutions does the ball make before being caught? Okay, so B. So you want to find the number of revolutions, means that we want to find theta. Okay, tapi jawapan yang kita dapat tu mesti dalam unit radian dulu. Okay, so we can use equation theta is equal to omega naught t plus half alpha t squared. Okay, so now we can substitute all the values, and it's equal to 157 and time is 0.795 plus half alpha is negative 289 and t squared 0.795 squared. Okay, so theta you akan dapat 123.9 radian. Okay, therefore the number of revolution, okay, the number of revolution, okay, we need to change 123.9 radian into revolution. Radian dekat atas, partner dia duduk dekat bawah. So 1 revolution equal to 2 pi radian. So cancel radian. So sekarang kita dapat unit kita dalam revolution. Theta is equal to 19.7 revolutions. Okay. So maknanya sebelum dia ditangkap, okay, dia telah membuat sebanyak 19.7 revolutions. Okay, so finish example number 4. Alright, question number 5. Here we have a cart with massless wheels of diameter 0.4 meter. So means that the radius is 0.2 meter. Okay, is moving up a straight ramp at 12 meter per second. Okay, means that given V, U, so it's given U. Initial speed is 12 meter per second. Tengok unit dia. Okay, unit dia 12 meter per second. Ini bukan omega ataupun omega naught. This is U. Okay, and then the ramp causes it to slow down at a rate of 5.4 meter per second squared. Okay, ini salah type ni. Okay, so means that the acceleration, okay, A, bukan alpha, unit dia meter per second squared. Negatif. Kenapa saya letak negatif? Sebab dia kata slow down. Okay. Ni. Okay. So, negative 5.4 meter per second, negative 2. So, question. How fast will the wheels be spinning after traveling 10 meters up the ramp? So, S is given 10 meter. So, now we want to calculate. Tulis itu how fast. Okay, will the wheels be spinning? Keyword dia fast dengan spinning. Okay, means that we want to calculate what is the value of omega. Boleh Tapi maklumat kita ada ni semua. Okay, maklumat berkaitan dengan linear motion. Okay, linear motion. Okay, contohnya kita ada, Okay, contohnya kita ada macam ni lah tadi. Okay, start from here to here. Okay, S is given 10 meter. Okay, so U is 12 meter per second. So masa dekat sini V dia berapa? Sebab dia adalah slowing down. The object is slowing down. So V ni mesti nilainya lebih kecil daripada 12 meter per second. Okay, so kita boleh kira V dulu. So V squared is equal to U squared plus 2AS. Okay, based on the information. So saya pilih untuk guna equation ini. So kita boleh masukkan U and then plus 2A, negatif jangan tertinggal. S is 10 meter. So V nanti you akan dapat, make sure you kira betul-betul. Ini adalah V squared. Okay, don't forget to take the square root. So 6 meter per second. Okay, maknanya dekat sini adalah 6 meter per second. Okay, so 6 meter per second is the tangential speed dia. Okay, in this direction. And how about omega? How fast will the wheels be spinning? Berapa kelajuan dia lah masa wheels to rotate. Okay, so omega, kita tahu V is equal to R omega. So omega is equal to V over R. Okay, so we can substitute omega is equal to V is 6, R is 0.2, and the answer should be 30. Okay, so omega equal to 30 radian per second. Unit pastikan tulis dengan betul dalam assignment awak. Okay, so finish example number 5.